So on worksheet 4 here, the kind of weird thing is the subclass has a new instance variable, but it's the same name as one of the superclass instance variables, which is bad design. Don't do this. But you can, it will compile, it will work. And so let's look at this. You have the superclass is the P class, which of course we don't say this, but it does extend the object class. It has two instance variables X and Y that are private as they should be. Has two constructors. You can see what they do. Has these 5 methods: fun, go, hoot, back to string, and that there's the code. Kind of try to fit it all nicely here. And now, one thing to keep in mind, we'll get to this later, but when you call the get class method, you call the get class method of this particular object, and so every P object will have a a P core, whether it's a P object or a Q object or some other type of P object. Anyway, we'll get back to that. This is going to seem kind of weird, but when you call this code, you won't always get P as a class name, is what I'm hinting at. Now, if you look at the Q class, I like to say it adds a new instance variable. Has two constructors that both call the superconstructor. On your worksheet, it doesn't say this, but of course that happens. It automatically is called the no argument superconstructor. And then it has 4 methods. Now, you need to analyze these. Does this class add any new methods? The answer is no. It also doesn't implement or override all the original. So it uses the original hoot method, but the other 4 it does override. All right, so would we say that the Q class extends the P class? Yes, because it adds a new instance variable. Although it doesn't add any new methods, it does add an instance variable. All right, let's run the code in the main method here. And like I said, I would write down the state of the object every step of the way. Now, once again, the reference variables of type P. We'll use that to store a P object here. Then later we'll store a Q object. Both work because they're both types of P objects. When we get down here is where we have to worry about which version of the method we're running, because here it's a P object, and so of course it's going to run the P version of the method. So all right, let's get into this. So we create a P object. We call this constructor, and it says to 70, which I wrote down. And then we call the fun method. Which fun method? Well, that would be the P version because it's the P object. And so return the X value. Notice the return type is double for some reason. And so the X value is 7, but as a double. Then you call the go method, and which is the P go method, which calls the P back method, which sets X to be 992. Hold on one second. Okay, that was more than I wanted. But you should show this. Next, we call the hoot method, which calls the go method, which calls the back method, which it sets to 992. Why, I don't know, but that's what it does. And so fine. We print the object, and when you print an object, you call the toString method, which in this case calls a class name and gets a class object for this object. It's kind of weird, but there is a class called class, which is what and basically the name of the class is P, obviously. And then the X value and the Y value, which were 992 and 0. And so that's what you would see from this line of code. And before we get into the next one, I want you to see, once again, this is what that object looked like. And when we set X to be 992, of course, this 7 would have been replaced with 992. That's pretty straightforward. Now we get into the Q object. And once again, as I've said, the subclass constructor calls the superclass constructor automatically if you don't do it yourself. And so it's going to call this constructor, which creates a P object that stores 7 and 0, and then builds on that to complete the Q object. So here's your picture of the Q object. And once again, this line of code replaces the reference that the variable 1 stores. And so the old object, the P object, gets garbage collected. So, all right, fine. That's the state of our object. Now we call this object's fun method, and this is a Q object. Let me say again, and if we go back and think like the compiler, every one of these methods was going to compile because the compiler is going to say, okay, this variable is the p reference. I know it's some kind of p object, and for all these method calls, it looks in the p class for every method called. Because all these methods exist there, it knows all this compiles. We didn't need a special typecast because the Q class didn't add any extra methods, so that was not an issue. Now that we're running it, we are going to call this particular Q object's methods, so every step of the way it should behave like a Q object. So once again, we call the fun method which fun method? Well, the Q version, which returns X, which X. And listen carefully. When you run code like this, it's going to access the instance variable that's in the same class as the code. Okay? So this code that we're running is going to access the Q instance variable, which is storing, oh, and I didn't write this, I forgot to mention this. I would label things like this. So you have two X variables. One's part of the P part of the class, and one's part of the Q part of the class. And so we're returning the Q X variable right here. And so this is going to return 23. Of course, that's a double. Now we call the go method. Of course, we're going to do the Q version, and then it calls the back method, which would be the Q version. So it sets the X value to be 45. Which X value? Once again, the X value that's the instance variable that's in the same class. So the Q X variable gets set to 45 here. We call the Q hoot method. No, wait. The Q class doesn't have a hoot method. I mean, it does, but it's because it inherited this one. So it's running this code. Now, so we're running the code in the P class, but it calls the go method. It's going to call the Q version. Once again, for every single method call, it looks in the subclass first to find the code to run. So even though the method call originated here, we're going to jump back to the Q class because there was a Q version of that method. So we call the go method, which calls the back method, which of course would be the Q version, which sets to 45 again, which once again is pointless, but what can you do? And then we call the toString method, which toString method, of course, the Q version, which is going to say the word class, then call the getClass method, and of course it's a Q object, and then it's going to show the X value, which X value, the one that's storing 45, of course. Then we call super.toString, and this is where it gets weird. I mean, not truly weird, but jump in here, we call getClass again. And you know, the key is that this is a Q object, therefore getClass is going to say Q again, even though it's calling it from inside the P class. It's this object right here that we're asking the class name of, and so it's Q still. And then of course you show the X and Y, and that'd be the P X and Y, and that's what I was saying before. Right now we're getting the P instance variables of this Q object. And so over here, once again, this X referred to the X that is part of that class. This X and Y refer to the X and Y that are part of that class. The last thing I'm going to say is, you know, once again, don't do this. Don't if you're going to add a new instance variable, give it a different name. Anyway, that is all.